All right, Calc students, this is week 5 of distance learning. Just 4 more weeks left. Thank you guys for your effort and all that you've done to put forward. I'll be grading your tests right away as soon as I can. Again, thanks for following through as much as you can. As I look at topics to cover, this is the next best piece to be able to prepare you for your next step. And it's integrals in logarithmic and exponential form. And so we're going to try and make it nice and easy. Your assignment is a little bit different this week. I'm going to give you the worksheet that we've done in the past. So it won't look the same, but simply just do your problems. And then for your assignment submission, just take a picture of that and paste it into the doc and submit it via Schoology if you can. But you actually have to view the PDF of the file in order to see the homework problems. But the answer should be posted as well. Again, please make sure you reach out to me if you have questions or concerns. Most days I sit here without anybody to talk to. I would love to be able to answer questions if you're stuck on a problem. It's kind of the highlight of my week for me. So what's the antiderivative of e to the x dx? Well, it is simply e to the x plus c. And the antiderivative of 1 over x dx is the natural log of x plus c. And so given those two properties, as you take notes here, those are going to set us up to be able to do all the rest of the problems we have for this lesson here. Okay, so I'm going to start out with a couple. And the first one is going to be the integral of e to the 3x dx. Now, this situation is just slightly different. We are going to use substitution. U is equal to 3x, so du is equal to 3 dx. I do not have a 3. So therefore, 1/3 du is equal to dx. Now my substitution becomes 1/3 integral of e to the u. You can see that the 3x is gone, the u takes its place, and 1/3 du takes the place of my dx. What's the antiderivative of e to the u? E to the u. So I get 1/3 e to the u, which is 3x plus my constant. And that's your first example for integrals of logarithmic and exponential form. Your second one is not quite as straightforward. As you look at this example, it's not 1 over x, okay? But you can see that you do have an x to the first power in the denominator. It's 2 over 4x plus 1. The key is to recognize that you have x to the first power in the denominator. And watch what happens if we try this substitution, where u is equal to 4x plus 1. Then du is equal to 4 dx. I don't have a 4 dx, I have a 2. So 1/2 du is equal to 2 dx. As I make this substitution right here, I have 1/2 integral du, and what I get rid of is my 2 and my dx. So what do I have left? I have 1 over this guy, which is u, 1 over u. Well, now it becomes very simple like we set up originally. The antiderivative of 1 over u is natural log of u. We have the 1/2. And the u is going to be 4x plus 1, and then plus c. In the answers, you might see absolute value expressions sometimes. Don't worry about that. We're not going to get into that, but you might see that in an answer key in this situation. So don't freak out if you see it. It's not a big deal, okay? My third example, this one should be right up your alley. The integral of 3x times 5 to the x squared dx. I'm sorry, we're going to skip that one. I don't like that problem. Didn't mean to write that down. Three x times e to the x squared dx. Okay? You can see if you take the derivative of x squared, you get 2x, not 3x. But that's going to be our substitution. U is equal to x squared. Therefore, du is equal to 2x dx. I don't have a 2, I have a 3. So if I divide by the 2 and multiply by 3, 3 halves du, is equal to 3x dx. Now I have my appropriate substitution. 3 over 2 integral du. I get rid of that, I get rid of that, I'm left with e to the u. And the antiderivative of e to the u is e to the u. And that's my third example. Example number 4 is a little bit different. And what I recognize here is that I have this natural log of x being squared. And the derivative of natural log of x is 1 over x. As you can see, I have an x in the denominator. So that's going to really help me out. If I set u equal to natural log of x, then du is equal to 1 over x dx. But I have a 4 in the denominator, so I'm going to multiply by a fourth. 1/4 du is equal to 1 over 4x dx. Notice that my substitution 1/4 integral du, I get rid of the dx and the 1 over 4x. I'm left with this thing squared, and this thing is u, so u squared. And what is the antiderivative of u squared? It is u to the third over 3, or multiplied by 1/4, u to the third over 12, plus a constant. What is u in this situation? U is the natural log of x. Natural log of x, quantity cubed, over 12, plus a constant. That's your fourth example. We're going to do 6, and then we're going to jump to a different video where we'll do 4 more. 5, we're going to have the integral of sine of x over 3 plus the cosine of x dx. Should we set u equal to sine, or u equal to 3 plus cosine, or u equal to cosine? Well, when you take the derivative, you want to come up with something else. So the derivative of 3 plus cosine is negative sine. The derivative of sine is cosine, but you don't come up with the 3. So the best substitution here is going to be u is equal to 3 plus cosine of x. Because when you find du, you get negative sine of x dx. And although that's not the same, just multiplying by a negative is really going to help get rid of that. So negative du is equal to sine of x dx. You can see my substitution now, negative integral du. I go ahead and I get rid of the sine of x and the dx. I'm left with this 1 over u piece. And u in this situation is that 3 plus cosine of x. The antiderivative of 1 over u is natural log of u, which in this case is 3 plus the cosine of x. That's my integral. So you just came out of a session where we did, all this area and volume, and very conceptual. This is much more analytical, much more, formulaic, and so algebraic in structure. And so hopefully this is a nice change. It doesn't make it easy, but without a doubt, it should hopefully be a little bit different skill. And for some of you, hopefully a nice change of pace as well. I know some of you are like, well, that last shells assignment where we did those revolutions, you maybe really liked that connected with you. I think it kind of had a little bit more of a beat of what you guys were able to handle via this distance learning and whatnot. So hopefully I'm getting better too, and you guys are getting better. So figuring it out. The integral of e to the root of x minus 2 over 4 roots of x. This will be our last example before we jump to the next video. What to do, what to do, what to do. Well, when in doubt, substitution is just a great option when you're dealing with any type of integral. And so in this situation, when I try to decide what I should substitute, what I should make u, a lot of times I look for that composition piece. You can see the square root of x minus 2 is sitting in that exponent there. That's part of that composition function, e to another function. So I'm going to say that u is equal to the root of x minus 2. So the derivative, or du, the derivative of negative 2 is 0, but the derivative of root of x is 1 over 2 roots of x, dx. Notice that the 2 sits in the denominator here. Here I have a 4. So if I multiply by a half, 1/2 du is equal to 1 over 4 roots of x, dx. Now in that situation, I have the 1 over 4 roots of x, which is exactly what I have there. 1/2 integral du. I can go ahead and get rid of that and that. What do I have left? I have e raised to the u. And a derivative of e to the u is simply e to the u, and u is the root of x minus 2 plus a constant. And there you have it. A couple of just words as you before you get to the next video. Next video is just going to simply build off this for the same area. But I know that some of you are, just about all of you are fully capable of taking Calculus 2 next year. It's just a matter of whether or not you want to dedicate that time and effort at the very front. And if you're taking Calculus 2 in your first semester or your second semester, and whether you're willing to kind of go through some of those struggles right away. But a lot of things we're covering is going to be right at the upfront part of that Calculus 2 piece. So really what you put in is what you get out in that situation. I don't want you guys to be scared of starting off taking Calculus 2. A lot of kids that have done it here at Albert Lee tend to have success. That said, if you take it over again, if you take Calc 1 over again, that's fine. It's a great way to establish a strong basis and understanding for Calc. A lot of you would be able to tutor people in the class if you did that. And there's nothing wrong with that. I entered college taking Calculus 1 and got through 10 math classes before I graduated. So you can do that as well. It's no big deal. Okay. The other thing is that I just want you to know that the school, we tried to be very understanding of the workload that you guys have. And I know that for a lot of you, especially, you're taking multiple advanced placement courses or CIS courses. And so there's possibly a very rigorous workload, especially during distance learning. School came out and said, you know what, on Wednesdays, we really don't want students to have anything to do. They should be able to get caught up, have work days, ask questions, so on and so forth. I hope that the way I've designed class, the intention was always never that you would have 3 days really of work, but that you would always have 2 days of work. And that may have started differently, say, that very first week, but from then on I said, let's just try to make sure we have 2 days. So, sometimes I have to have 3 videos in order to get that through because I'm only allowed to record 15 minutes at a time. But I really hope that the 2-day approach is working for you guys. The assignment that you have is just one assignment that I've given in years past. I've really tried to reduce it. So if you're struggling to keep up, please reach out to me. Again, I sit a lot of time by myself just waiting for people to ask help. So don't hesitate to reach out if you have questions. And I know I went through a lot of that quickly. If you need to go back and pause as you're watching, so be it. I just want to try to make sure I use my 15 minutes wisely. Have a great day. I miss you guys so much. I can't wait to see you sometime soon. Have a good one.